In the above invocation of CP, I copied the license file from the KNLM directory. The resulting copy is a file in my current working directory called ABC. ABC is a copy of license. We can use the diff command to verify that the two files are identical. Another way to invoke CP is by giving CP a destination directory. For example, let's say we wanted to copy the file ABC into the directory baz. To do so, we can call CP using ABC as the source file and baz as the destination directory. As you can see, after the above invocation of CP, the baz directory now contains a copy of ABC. Command line basics, using CP to copy a single directory. The CP command can be used to copy files and directories. Let's say we want to make a copy of the KNLM directory. The first thing we might try is a simple invocation of CP. What just happened? We tried making a copy of the KNLM directory called wxyz. If we run ls, we see that our attempts to copy the KNLM directory failed. By default, CP will not copy directories. To get CP to copy a directory, we must add an additional option when invoking CP. If CP is invoked with the -r flag, it will copy directories, including their contents. As you can see, After the above invocation of cp with -r, the wxyz directory now exists and is a copy of the kenlm directory. Let's take a look at command line basics, using echo to print simple strings. Echo is typically used to display a single line of text. Here, the message was, "Hello world." Echo prints this message to standard output. Notice that the message was not printed until after the Enter key was pressed. While it may not always be necessary to enclose the message within quotation marks, doing so is good practice. Let's use echo to display another simple message. As you can see, the message we gave to echo is printed to standard output. It is possible to redirect the standard output stream to a file, or use a pipe to send it as input to another process. In this case, we aren't doing either of those things. As a result, we see the default behavior, where messages sent to standard output are displayed on the terminal. Let's use echo to display some more simple messages. Let's take a look at command line basics, using echo to display multi-line messages. Echo is typically used to display a single line of text. However, echo can be used to print messages that span multiple lines of text. Let's start by using echo to print a simple message consisting of a single line of text. Now, let's try again, but this time we're going to make a mistake. Notice what happened. We typed the opening quotation mark, then we typed the message, then hit the Enter key. Instead of printing our message, we see something that looks like a greater than sign. Notice that we forgot to type the closing quotation mark. Let's add the closing quotation mark, then hit Enter again. Notice what just happened. Our message was printed, but in addition, an extra blank line was printed. Do you see the extra blank line? It's there. Let's try another example. In our next example, the second line will contain more of the message. Here, it should be clear that echo printed a message that consisted of 2 lines of text. When entering a multi-line message in this manner, we're not limited to just 2 lines. The contents of our message will continue until we enter a closing quotation mark. After we enter the closing quotation mark and then press the Enter key, the entire multi-line message is printed to standard output. Let's take a look at command line basics, using echo to display messages with escape sequences. Echo is typically used to display plain text messages. However, echo can be used to print messages that include special characters. Let's start by using echo to print a message consisting of a single line of text. Now, let's try again, but this time we're going to include something new. And to do so, we're going to take a look at the documentation for echo. The documentation for most commands is found by accessing the command's manual pages using the command man. But echo is special. Echo is a bash built-in command. The documentation for bash built-in commands is obtained using the command help. By reading the bash help page, we can observe that echo is capable of reading a number of \escaped characters. A \escaped character is just a character that is immediately preceded by a / character. Of the \escape sequences you see here, it's likely that you'll only ever need to use 1 or 2 of them. The 2 that we'll examine here are the escape sequences for new line, \n, and for horizontal tab, \t. Now, let's try printing our message again. However, this time, instead of placing a space between the 2 sentences, we're going to try to place a tab character between the 2 sentences. Recall that the escape sequence for a horizontal tab character is \t. What just happened? The escape sequence \t represents a horizontal tab character. We wanted echo to replace \t with an actual tab character. Let's take another look at the help page for echo. In the above invocation of echo, we did not use any options. Notice that echo has an option, -e, that does exactly what we want. If echo is called with the -e option, then echo will replace the escape sequence with its corresponding literal character. Let's try again, this time using the -e flag. it looks like there's a space character between the sentences, but it's actually a tab. To see the difference more clearly, let's try again, but this time let's add another tab. Now we can see a difference. Let's try again with 3 tabs. Compare that to the same thing, but with 3 spaces between the sentences. Now, let's try again using the escape sequence for a new line, \n. Whoops, I did \t again. Let's try again with \n. Now let's add another new line. And now again with 3 new line characters. By using escape sequences, we can use echo to print a multi-line message, even while we enter the command using a single line. Let's take a look at command line basics. Grep. The grep command finds text patterns in files. It prints out all the lines containing a matching pattern. Grep can match very complex patterns with the use of regular expressions. Let's take a look at grep's man page. Grep searches the named input file or files, or standard input if no file is named. Let's use grep to find all the files that have the word zip in the name in the directories bin and user bin. To do this, we first use ls to list the files in those directories. Then pipe the result to grep to search for the pattern zip. A list of file names containing zip is displayed. Grep pattern matching is case sensitive by default. Let's try to list the file names in bin and user bin that contain the word zip in uppercase. We get 0 matches. To allow grep to ignore case when matching the pattern, we can use the -i flag with grep. The -i flag specifies that grep should ignore case distinctions. If instead
of a list of lines that match the pattern, we want a list of lines that do not match the pattern, we can use the -v flag with grep to invert the match. We now get a list of file names in bin and user bin that do not contain the word zip. To output the number of matches instead of the actual matching lines, we can use the -c option with grep. Here we observe that there were 19 items which matched the pattern zip. Let's take a look at command line basics, head and tail. Head and tail are commands that print the first and last parts of a file, respectively. By default, head prints the first 10 lines of a file, and tail prints the last 10 lines. Let's take a look at their man pages. By default, head prints the first 10 lines of a file to standard output. This can be changed using the -n flag to specify the number of lines instead of assuming the default of 10. Tail behaves very similarly. Let's create a text file and use head and tail to examine its first and last lines. We can observe that foo.txt now contains a sorted list of the files in user bin. We can use head to display the first 10 lines of the file. We can use tail to display the last 10 lines of the file. To view a different number of lines, say the first or last 5 lines of a file, we can use the -n option with head and with tail. These are the first 5 lines of foo.txt. And these are the last 5 lines of foo.txt. Head and tail can also be used in a pipeline. Let's list the last 7 items of the contents of the directory user bin. To do this, we will use ls to list the contents, sort to sort them, and pipe the output to tail with the appropriate option, listing the last 7 items in the directory user bin.
Let's take a look at command line basics. Echo. Let's take a look at Echo's man page. The command echo accepts 0 or more strings provided by the user, and prints those strings to standard output. If the standard output of echo has not been otherwise redirected, then those strings will be displayed to the screen separated by spaces. As we can see, echo printed the string hello. If we provide more than one string to echo, it will print each string and will put a single space between each pair of strings. Here's the first string, followed by a space, followed by the next string. If we provide more than one space between each string, echo ignores the extra spaces and only a single space is printed. If we want to print a string preserving all spacing and other formatting, we can enclose the string in quotation marks. When we do this, echo will treat everything within the quotation marks as a single string. Let's take a look at command line basics. Wildcard expansion. Let's try to use echo to display a single line of text. See that the line we typed is displayed just as we typed it. Extra white space in the arguments of echo will be removed in the output. Here we typed extra spaces. But the output in those locations only included a single space. When there are special characters in the line of text, we see something else. To check this, let's cd to a different directory and look at the contents of that directory using ls. Now, let's try to use echo with a wildcard character as the argument. The star or asterisk here is treated as a wildcard character. Notice, echo did not display the character star itself. Instead, it displayed a listing of the files in the current working directory. Notice that this output of echo is the same in terms of the files listed as that we saw with ls. This is because before the echo command is executed, the shell itself has expanded the wildcard character into a list of file names in the current working directory. It is very important to understand how the shell carries out expansion for different kinds of characters. Echo is a good way to observe the effects of different special characters and their respective expansions before we use these special characters with other commands. Let's take a look at command line basics. Path name expansion. Bash is capable of performing certain types of expansions. Let's try to use ls to see how path name expansion works. In this command, the wildcard character has been expanded. The result is a listing of all file names in the specified directory whose file names end in .h. Let's try another example. Here, the wildcard expanded again, resulting in a list of all files in the user bin directory whose file names begin with the characters py. Let's take a look at command line basics. Tilde expansion. Tilde expansion is a special expansion involving the tilde character. When the tilde character is used at the beginning of a username, it expands into the name of the home directory for that user. Let's try to use echo to see how tilde expansion works. Here, we see an expansion resulting in the full path to this user's home directory. If no username is supplied after the tilde character, the result expands into the home directory of the current user, which in this case is lane S. We observe here that the tilde character has been expanded into the home directory of the current user. Let's take a look at command line basics. Arithmetic expansion. Arithmetic expansion allows the shell to perform calculations before passing the results to a command as arguments. Arithmetic expansion uses the $sign character and double parentheses around an arithmetic expression. Let's use echo to see how arithmetic expansion works. See that this arithmetic expression, 7 plus 3, has been calculated with the result 10. Note that arithmetic expansion only supports integers, or whole numbers. The expansion would result in an error if decimals are present in the expression. see that bash has displayed an error message for the decimal. Invalid arithmetic operator, indicating that the decimal point caused the error. Arithmetic expansion supports addition, subtraction, multiplication, integer division, modulo or remainder, and exponentiation. Arithmetic expansion may also be used alongside text. Let's try to use echo to see how the integer division and modulo operators work. If the result of the division is not an integer division will cause the result to be truncated to the integer part and will not be rounded. So, using integer division, 7 divided by 2 is 3, with a remainder of 1. The 1 was calculated using the modulo operator. The 3 was calculated using integer division. Now, let's use echo to observe how the exponentiation operator works. This calculation has raised 5 to the exponent of 2, or 5 squared, which is 25. Inside the double parentheses of an arithmetic expression, it is possible to nest another arithmetic expression. Here we have nested an arithmetic expression, 1 plus 1, within a larger expression, 5 to the power of 1 plus 1. Here, the inner expression calculates 1 plus 1, resulting in a value of 2. The outer expression performs the exponentiation, 5 to the power of 2, resulting in 25. We can also use single parentheses to group the order of operations without actually causing a second expansion of the arithmetic expression to occur. This will calculate the same result of 25 using only one arithmetic expansion instead of 2. Let's take a look at command line basics. Brace expansion. Brace expansion creates multiple text strings from a pattern. The pattern takes the form of an unchanging preamble followed by a variable expansion component followed by an unchanging postscript. The varying part of the pattern is enclosed by a pair of curly braces. The constant part before the opening brace is called a preamble, and the constant part trailing after the closing brace is a postscript. Let's try to use echo to see how brace expansion works. This pattern has expanded into 3 text strings. Each string has the same preamble at the beginning, and the same postscript at the end. The middle part of each string varies and is present in the same order as specified in the pattern. Brahms, Beethoven, Bach. Brahms, Beethoven, Bach. If we had changed the order in the pattern, the order would be correspondingly different in the created strings. Both the preamble and the postscript are optional. Here, we expand a pattern with a preamble, but no postscript. Here, we expand a pattern with a postscript, but no preamble. And finally, we expand a pattern with no preamble and with no postscript. Now, let's try to use brace expansion with a preamble that includes white space. Here, Bash considers I, love, and Brahms, Beethoven, Bach to be separate tokens. As a result, the brace expansion is performed, but I, love is not considered a preamble to the brace expansion. To get around this problem, let's try enclosing I love in quotes. This is slightly better. Now Bash sees 2 tokens instead of 3. The first token is the quoted string I love, and the second token is Brahms, Beethoven, Bach. But bash still, in this case, does not consider I love to be a preamble to the brace expansion. We can fix this by placing the quoted string immediately adjacent to the brace expansion with no intervening spaces. Now, in this case, bash sees only one token, the entire string, where I love is taken to be a preamble because it immediately precedes the opening brace with no intervening white space. Finally, let's add an additional space, but place it inside the quoted preamble, and also add a postscript. I'm adding a space, but placing it inside the quoted preamble, and leaving no intervening space between the preamble and the start of the pattern inside the braces. Finally, I'm going to place a postscript, a single period. A brace expansion can contain a comma-separated list of strings, as we have just seen. It can also contain a range of integers or characters using the operator ... Let's try to use echo to see how to specify a range in brace expansion. Notice that I am not placing a space between the preamble and the pattern to be expanded. An underscore is fine, but a space is not. This is expanded to 5 strings. Number 1, number 2, number 3, number 4, number 5. We can also use a sequence of characters with the ... operator. Here, the pattern has expanded to a sequence of lowercase letters. Integers within a brace expansion can be zero padded. Here, we have zero padded numbers 1 through 9. And here we have zero padded numbers 90 through 100. Brace expansions can also specify numbers in reverse order. Here, we have something expanded to strings where the numerical part is in reverse order from 5 through 1. Brace expansions can specify a range of characters, as we have seen above, and character ranges can also be reversed. We observe that this character range has expanded to lowercase characters in reverse order. Brace expansions can also be nested. Let's work through this expansion part by part. In the expansion, the preamble, lowercase a, and the postscript, lowercase b, are constant. In the variable part of the expression, the brace expression is a list of items separated by comma. So, bash starts with the first item, A12. This is a brace expansion as well. This expands to two strings, uppercase A1 and uppercase A2. So, the first two strings produced for the entire expansion are A1B, and A2B. Now, the first nested brace expansion is complete. Bash now starts with the second item, B34. The next two strings produced are the expansions B3, which is then prepended with the preamble A, and postpended with the suffix B, followed by the expansion B4, ultimately resulting in A, B4, B. Brace expansions are particularly useful for making lists of files or directories where the names are of a fixed format. For example, imagine that we want to organize a sequence of photos by month and year. We may wish then to create a series of directories in numeric format in chronological order. Instead of creating the directories one by one using the command mkdir by hand, we can use a command using brace expansion. Now, using a single mkdir command, we can create a series of directories. With this one command, we have created directories for all of the months over a range of 10 years. Let's take a look at command line basics. Path name expansion. Bash is capable of performing certain types of expansions. Let's try to use ls to see how path name expansion works. in this command, the wildcard character has been expanded. The result is a listing of all file names in the specified directory whose file names end in .h. Let's try another example. Here, the wildcard expanded again, resulting in a list of all files in the user bin directory whose file names begin with the characters py. Let's take a look at command line basics. Command substitution. Command substitution allows us to use the output of a command as an argument of another command. This is done by using the $ character followed by a pair of single parentheses. The command whose output we want to use goes inside the parentheses. Let's begin by using ls to list the contents of the etc x11 directory. Now, let's enclose this ls command using the command substitution syntax. Here, we have first executed the command ls to output a list of items in the etc x11 directory. Command substitution then causes this output to be used as the arguments to echo. Echo finally displays a list of those items. Note that command substitution is very different from piping. Piping allows us to redirect the output of one command to the standard input of another command. For example, a pipeline could be used to pipe the output from ls to the input of sort. If we were to reverse that pipeline and attempt to pipe the output of sort to the input of ls, this wouldn't work and it would have no effect on ls. Because ls does not make use of standard input. On the other hand, command substitution allows us to use the output of one command as the argument or arguments of another command. Therefore, if we wish to configure the behavior of a command such as ls with the output of another command, we would use command substitution, not piping. Let's try to use command substitution to provide arguments to ls. In the outer command, we are attempting to use ls with the -l flag to create a long listing in this format. We're using the command which with an argument of cp to determine the full directory, the full absolute path to the cp command. The result of which is bin cp. Bin cp is then substituted as the argument to ls-l, resulting in the output that we see here. There is also an older syntax for command substitution that we do not recommend that you use. However, you may occasionally see it. That older syntax uses backticks instead of the $ parentheses syntax. Again, we do not recommend using this backtick syntax. However, it's important to be able to recognize it if you see it in someone else's scripts. Let's take a look at command line basics. Escaping characters. By default, the $ has special significance to the shell. Use of the $ here tells bash that we want to refer to the variable called user. Bash then looks for a variable called user, gets the contents of that variable, and replaces user with the contents of the user variable. If we want to print a string containing an actual $, we can precede the $ with a backslash. The character we wish to quote, in this case a $, is then preceded with a backslash, which prevents this particular $ from being interpreted as a special character. If that $ is followed by text, then the quoting of the $ prevents expansion by treating the $ as an actual literal $ rather than as a special character, which in normal cases would indicate that expansion is to be done. This type of quoting is used to selectively suppress expansions. It is handy when we occasionally want a special character such as the $ to appear as itself. Let's see the effect of this type of character escaping in commands. In this command, there are two expansions that could take place. Here, we have a variable that is expanded to the value of that variable, here, lane s. Secondly, escaping transforms \$ into the literal $ character and prevents $5 from being treated as a variable expansion. The $ is a character with special significance to bash. There are other characters that also have special significance to bash. These include the $, which we just discussed, the exclamation point, the ampersand, the backslash itself, and the space character, which bash uses to delimit tokens. Any of these special characters can be escaped using a backslash. Since the backslash is itself a special character, if we want a backslash character to appear as ordinary text, we would also need to escape it with a preceding backslash character. Here, the first backslash character escapes the second backslash character, resulting in a literal backslash character. Because this second character was escaped, it does not in turn escape the dollar sign, and the dollar sign here normally acts as normal to cause variable expansion. See that we get this backslash character in front of the username. Let's see an example using multiple other escaped characters. Here we have escaped a literal space, an ampersand, another literal space, and an exclamation point. The ampersand and exclamation point have special significance to bash and can be explored in other situations. Needless to say, without this escaping, we would not get this exact output. Another way that we can confirm that special treatment is occurring here is by using brace expansion. Recall from our discussion of brace expansion that normally brace expansion with a preamble needs the preamble to not be separated by a space. The reason is that a preamble is only considered if it is part of the same token as the token containing the braces. Here, we're going to see that because we are using the backslash to escape the spaces, this entire string is taken to be a single token by bash, meaning that we will get greetings and salutations taken as the preamble to this brace expansion. We confirm this here. We get greetings and salutations, Joe, greetings and salutations, Jane. Let's take a look at command line basics. Double quoted strings. Many times when passing arguments to a command, it is desirable for a string containing spaces to be treated by bash as a single token. As we previously discussed, one mechanism for obtaining this behavior is to escape the relevant space characters using the backslash character. Here, we have created a file with literal spaces in the file name. An alternative method to using escaped spaces is to use double quoted strings to enclose the entire file name. By first quoting the string myfirstfile.txt, bash treats this entire string as a single token. Within double quotes, some characters which normally have special significance to bash are treated as normal characters without special meaning. Normally, the ampersand character has special meaning to bash. Inside the quotes, that special meaning is lost. Wildcard characters, including the star, the tilde character, curly braces, will all be treated as ordinary text and not special characters. Within double quotes, therefore, the following operations are suppressed: word splitting, path name expansion, tilde expansion, and brace expansion. Let's observe the effects of double quotes in some commands. In this command, the argument to echo includes extra spaces between two of the words. The output of echo does not have these extra spaces between the word a and the word test. This is because, without double quotes, space is interpreted as a special character for the purposes of performing word splitting, and the extra spaces are simply ignored. If we put this argument in double quotes, the spaces within the string are no longer interpreted as special characters. Rather, the entire quoted string is treated as a single token for the purposes of word splitting. All of these spaces remain in the output as ordinary text. Let's try a command where double quotes will suppress expansions. We observe in these examples that when the tilde is used outside of double quotes, the tilde expands to the full path name of the current user. We also observe that when the star wildcard character is used outside quotes, it is expanded here to bar and here to foo. However, when the same string is enclosed within double quotes, the tilde expansion and the wildcard expansion are both suppressed. The tilde is treated simply as a tilde character. The star character is treated simply as a star character. Let's look at another example. Here, we observe brace expansion in action. The preamble color, followed by red or green or blue. Color red, color green, color blue. This is the result of the expansion. When we enclose this same string in double quotes, the brace expansion does not take place, and the curly braces are treated simply as literal curly brace characters. There are other special characters that retain their special meaning inside double quotes. These exceptions include the $sign character, curly braces when used with the $sign character, single parentheses when used with the $sign character, double parentheses when used with the $sign character, backticks, and the backslash character when used to escape these other special characters. This allows the following operations to be carried out within double quotes: parameter expansion using the $sign, arithmetic expansion using the $sign in parentheses, and command substitution. Let's try a command that is not affected by these double quotes. This command contains two examples of parameter substitution. Here using a $sign and curly braces, and here using simply a $sign. The result of that expansion is observed here for this first case, where the variable user is replaced with its value, lane s, which is the name of the current user. And again, the variable user is replaced with the value of that variable, lane s. Here, arithmetic expansion is performed. The $sign double parentheses indicates that arithmetic expansion will be performed. The arithmetic expression 2 plus 2 is replaced with the result of that arithmetic operation, the integer 4. And finally, command substitution. The command cal is run, and the output is substituted for this expression here. All of these operations expanded as expected, despite being within double quotes. Parameter expansion gives us the value of the variable named user. Arithmetic expansion calculated the result of 2 plus 2. And command substitution has displayed the output of the command cal. Let's take a look at command line basics. Single quoted strings. Many times when passing arguments to a command, it is desirable for a string containing spaces to be treated by bash as a single token. As we previously discussed, one mechanism for obtaining this behavior is to escape the relevant space characters using the backslash character. Another alternative is to enclose the string within double quotes. A third alternative, which we will discuss now, is the use of single quotes. Just as when double quotes are used to enclose a string, when a string is enclosed in single quotes, that string will be treated by Bash as a single token. Recall that when using double-quoted strings, word splitting, parameter expansion, tilde expansion, and brace expansion are suppressed, but parameter expansion, arithmetic expansion, and command substitution are still performed. When a string is enclosed within single quotes, none of these expansion operations are performed. Let's look at an example, but first let's create a new directory containing a couple of empty text files. Now, let's try a command involving tilde expansion, brace expansion, command substitution, arithmetic expansion, and parameter expansion. Bash begins by tokenizing the argument line, resulting in 7 tokens which are passed as arguments to echo. The first argument is the plain text string hello, comma. The second argument is the plain text string world. The third argument is the string tilde/example/star.txt. This argument is expanded using tilde expansion and wildcard expansion into home lanes example a.text and home lanes example b.text. The fourth argument is 3.7 within curly braces. This is expanded using brace expansion into 3, 4, 5, 6, 7. The fifth argument is file etc cron tab within dollar parentheses. This expands via command substitution into the result of performing the file command with the argument etc cron tab, resulting in etc cron tab : ASCII text. Just as if we had typed it at the command line. The sixth argument is the arithmetic operation 2 plus 2, which is expanded using arithmetic expansion into the result 4. The seventh argument is the variable user, which is expanded using parameter expansion into lane S. The echo command prints each of these results separated by a single space character each. Now, let's see what changes when we enclose this argument list within double quotes. First of all, we can see that the literal space characters in the string are preserved. This is because the entire quoted string is treated by bash as a single token. When the string is enclosed in double quotes, tilde expansion is suppressed. Wildcard expansion is suppressed. Brace expansion is suppressed. But command substitution still takes place. Arithmetic expansion still takes place. And parameter expansion still takes place. Now, let's see what happens when we enclose the argument within single quotes instead of double quotes. Again, we first see that the literal space characters are again preserved. This is because, as before, the entire quoted string is treated by bash as a single token. When the string is enclosed in single quotes, all forms of expansion are suppressed. Tilde expansion is suppressed. Wildcard expansion is suppressed. Brace expansion is suppressed. Command substitution is suppressed. Arithmetic expansion is suppressed. And parameter expansion is suppressed. Instead, we get the exact literal string that we typed in being returned by the echo command.